Hello, it's Miss Wesley, and it's statistics time yet again. So go ahead and open your stat packet up to page 13 if you'd like to follow along. Today's a big day because we've spent the past few lessons crunching a bunch of numbers, finding lots of statistics about sets of data, measures of center, measures of variation. We haven't paused for a second to talk about the ideology behind it. So for instance, sometimes someone will throw a bunch of statistics at me, give me a bunch of percentages to try to prove their point, and I don't always trust it. I like to say, where'd you get your facts? Where are those stats coming from? How did you sample your population? And today we'll talk about how to sample, how to conduct surveys, and how to avoid bias when you're doing just that. You'll notice at the top of this page, I changed the warm-up a slight bit. I decided because I didn't have the numbers for your siblings yet, I changed the directions to, we're going to find standard deviation and mean for our house numbers for each member of our class. There's 28 numbers here, from the 9 is the first one to the 410 at the bottom. I included myself on the list as well, so there's 28 of us total. And in a second, we're going to pause the video so you can get those numbers into L1 and try this along with me. While you're getting your calculator ready, here's your joke. Why did Cinderella make a really bad soccer player? Guys, she ran away from the ball. She kept running away from the ball, and that's why. Go ahead and pause, enter the numbers in, then join me back in here. Let me go to Stat and Calc, one variable statistics for our house numbers. L1 looks good, and we get that the mean, let me jot this stuff down, we get that the mean house number for our class is going to be around 261 if we round it to the nearest whole house number. So the mean is about 261. The standard deviation, let's go for population standard deviation for the whole class. So sigma is going to be rounded to the nearest whole number, a 158. Okay, so we pretty much answered the question here. That was quick. I was looking at the numbers, though. I was wondering if any of us are a high or a low outlier. I'll give you a hint. My house number is one of the lowest ones on this list. I'm wondering if the 9, the 57, the 23, are those low outliers? And is maybe the 709, I mean, that one's so much higher than the others. Maybe that's a high one. And I could put myself out of my suspense by looking at this 5-number summary. Let's get the IQR and find outliers. So IQR is Q3, 358.5 minus Q1, 123.5. You can go ahead and type that in. I think I did here on my side calculator. I got an IQR of 235. That is the IQR. Let's refresh the 1.5 times IQR criterion. You've got a high and a low cutoff. So Q3 plus 1.5 times that is your high cutoff. 358.5 plus 1.5 times 235 gives you the high cutoff, and the low cutoff is going to be the 123.5 minus 1.5 times 235. It's a little sloppy there. Low cutoff first. 123.5 minus 1.5 times 235. So low cutoff is negative. This one wasn't that cool. Negative 229. Anything below that? I don't know anybody that has a negative house number. But what about the high one? Is 709. Whoever this person is, are they unusually high for the rest of the set? And it's 358.5 plus 1.5 times 235 gives you 711. Wow. If we were to make a box plot, there would be no X's denoted as outliers on this box plot because 709 checks out. Just not barely, usually high. Okay, let's talk statistics now again. Population versus sample. So we're going to fill in some definitions here. It says a population is going to be all members of a set. I'll record that here. We'll say all, emphasis is on all, members of a set. Lately, we've been talking about population standard deviation more than sample because this is the entire population of our class, even me included, in that set of house numbers. A sample would be, man, I didn't have time to talk to all 28 of you for some reason, so I'm just going to talk to a subset. I'm going to pick, like, I don't know, alphabetically the first 5 of you and use you as my sample. So that's just going to be part of a population. Can we discuss that for a second? I wonder if this were you doing a statistical study and you're trying to gather info about a group of people, why would you use a sample instead of talking to the whole population? Well, honestly, if it was just our class, I shouldn't be lazy. I should talk to every single one of you. It's only 28 of us total. But what if it was, I don't know, every single person in our school? I cared about all of HMHS. And what if I didn't have time to get around to everyone? I know there's online ways I can do it and other ways, but sometimes it's either too expensive, it takes too much time, or it's too inconvenient to talk to all members of a set. Can you think of a case Right now in our politics, where we really want to talk to an entire population, ever heard of a census? I'll put that in parentheses. A census, such as the 2020 census that's happening right now, is where they're trying to gather data about every single person in the United States. I mean, it is pretty crazy, and lots of times there's going to be error in that. But a census would talk to all members of the population. Generally, we're going to deal with samples, because if I'm talking about everybody in New Jersey or everybody on the East Coast, it would be virtually impossible, right? Not feasible to talk to everyone. There are 4 types of samples that are the most common and that we should talk about. They each have their pros and cons. Convenient sample. You select any members of the population who are conveniently and readily available. So for instance, I'm just going to say, I don't know, a random group of kids walks through the cafeteria door. It's convenient for me to stay in one spot. I'm going to poll the students who come into our cafeteria. Self-selected sample. Select only members of the population who volunteer for the sample. I put out a statement online and I say, if you'd like to help out and participate, you can self-select. You can select yourself to be part of the study and respond. Systematic sample. Order the population in some way and select from it at regular intervals. I've already mentioned alphabetical order is a really good example of a systematic sample. I'm going to put you guys all in alphabetical order, and I'll pick every 5th member on the list or every 4th member on the list. It could be you look at everybody's student ID numbers, right? Put those in numerical order and then choose at random. Versus a random sample. A random sample, all members of the population have an equally likely chance of being chosen too. And this is what you're striving for. You're striving for not just the people who go online a lot, not just the people who eat in the cafeteria versus maybe the kids that have choir and eat somewhere else. You want everyone in your study to have an equally likely chance of being chosen. Versus bias. Bias is what we are trying to avoid. A systematic error that's introduced by a sampling method, and we'll see that in some of these examples to come. So let's analyze these sampling methods. The Haddonfield Sun wants to find out what % of the town population is going to favor a property tax increase, but to raise money for local parks that might appeal to people. What's a sampling method used for each situation, and does it have bias? Feel free to pause and make your own decisions about these before I talk through them, but a lot of these are opinion-based. I'm just going to offer one side of the story. So it says in Part A, an article in the newspaper on the tax increase invites readers to express their opinions on the newspaper website. I got to think of how I would respond to this. So what would be the sampling method here? And I'm going to say this is a self-selected sample, because the readers are being invited, if they want to participate and express their opinions. Do you think this could have bias? And again, you could go any which way on this one as long as you back up your statement. I just want to see a reason behind it. And I might say one possible bias could be that people who are not in favor of the tax, so people against the tax, might organize a campaign to get friends to participate or to visit the website, right? That could be a potential bias. I could say, oh, I'm really against this tax. I really don't want it to happen. I'm going to just talk to my closest friends and see if they will self-select, participate, so it can look like more people are against this tax. So that would be one error that could happen. B says a reporter interviews people leaving the playground at Lizzie Haddon. Okay, so what type of a sample is this? To me, it's kind of like that cafeteria example. It's a convenience sample, because I'm going to conveniently station myself at the playground at Lizzie Haddon, one of the best outdoor basketball courts around here, if you ask me. And I'm just going to talk to the random people that walk by. It's convenient for me because I don't have to go door to door to a bunch of different spots. Could there be bias if you're trying to gauge whether people are in favor of this property tax? Well, I'm at a park, right? I'll say because the people I'm talking to, they're at a park in particular, and the whole thing's about a park. The sample may over-represent park supporters. I just get nervous about that one because you're only talking to people who are coming to a park anyway, so they might, by nature of them being there, just be more inclined to do anything that would support a park. In the third situation, we've gone a little bit more random. I kind of like this one. They're picking up a phone book, and they're going to call every 50th listing from the local phone book. This is a systematic sample for sure. But it was funny. I actually had to ask someone yesterday, does the phone book still come out? Do we still get this thing called a phone book? I remember it was this big yellow book, used to come to your house, had a listing of everyone's phone numbers and addresses in it. And there might be a problem with that. Maybe there's a link. So I could say could have bias if there's a link between the people you're going to get listed in the phone book, so people listed in the phone book, and people who pay property tax. That might be a problem, right? The people against this tax might be the ones who actually have to pay it, and they're the homeowners. If you decide that you want yourself listed in a phone book, that means you probably pay property tax and you own a home. So there could be a little bias in that situation. I want to scroll down. I want to go to page 14 and talk about different study methods too. And some of these you may have heard of before. We're just going to put names to them so we can talk about them in an organized way. In an observational study, it is what it sounds like. I do some experiment, I observe members of a sample, and I figure out the results. I summarize my observations. In a controlled experiment, you're going to take a sample of people, put them into two groups. You impose a treatment on the one group, whether it's we're going to make you guys take this certain drug or change your certain life pattern. Then take the other group and the treatment is not imposed on them. Maybe they don't get the drug, they get a placebo, which is just like one that doesn't have an effect. And you're going to compare the results of the two groups. In a survey, you know what a survey is. You're just going to give, I've given you guys surveys before this year, give every member of a sample of the population a set of questions. And we're going to see some of these examples down here. Name the type of study used, and do you think that the study is reliable? Do you think you can make a general conclusion based off of this study? Researchers randomly choose two groups from 10 volunteers. Over 8 weeks, one, I like this, eats ice cream before going to bed. Little known fact about Miss Wesley, might have told you this. I do that every single night. Just about every night before bed, I have double fudge brownie ice cream, sometimes with raspberries. And then the other does not, and they're wondering, is that affecting your dreams? Is that affecting your sleeping patterns too? So, which type of study is this? Well, this looks like you have a controlled experiment. You have the two groups present. One is actually eating the ice cream before bed, the other isn't. Do you think this would be reliable? Looking at it, making a general population conclusion about the whole population based off of just 10 volunteers, I'm going to say not reliable, in my opinion. Probably too small of a sample size. And you have to watch out for that, right? You got to look at how many people are you looking at before you make these conclusions. Students in Mr. Smith's environmental science class record the height of bean plants as they grow. That is an observational study. And for this one, I would say probably reliable, not just because I love Mr. Smith. Probably reliable because they're just observing the bean plants. What could go wrong? If you had to hunt for something that would make the results not good enough to make a conclusion, maybe, I'll say, but you've got these other, I call them lurking variables or lurking factors, could affect the results, right? A lot could go different or wrong when you're trying to raise plants. I know this. Amount of sun, amount of soil, amount of water, amount of fertilizer, right? Really could affect the results. So you have to make sure you do it in as fair a way as possible. How about if student council members ask every 10th student in the lunch line if they like the cafeteria food? Well, that looks like a survey to me, right? They're surveying every 10th student in the lunch line, asking them a specific question. How reliable is this? I'm sorry, student council. I'm going to say not really reliable. They really want to get, do they want to get the whole population's idea of the cafeteria food? They're just asking people in the lunch line. So people in lunch line probably like cafeteria food, right? Probably like cafeteria food. we might get biased results there too. So we'll leave it at that for a second. There are a few other good questions here on the next page. They talk about designing a good survey. Like, let's say you're trying to figure out if the random Joe person is going to know the face of the Olympic swimmer who in 2008 and some other Olympics won a bunch of gold medals. Just be careful how you ask the question. Hold up a photo of the guy and say, who is this? You don't have to lead them by talking about the medals or talking about your opinions of the person. Just be careful. And don't show them this picture because it says his name right on the cap. All right, see ya.